Hey there, welcome to Metana, Web3's leading bootcamp provider where we break down cutting-edge tech so anyone can understand it. And since you clicked on this video, there's probably one big question bouncing around in your head. What on earth is a blockchain? Well, today, we're going to be finding the answers to that question, and even show you how you might have used a simplified version of a blockchain some point in your life, without even realizing it, because I certainly did. You see, back when I was in college, me and my friends were out for dinner once, and finally when the bill came out, one of my friends said, "Hey, don't worry about it. I got the bill this time, someone else can cover it next." And we did just that. We let him cover the bill today, and everyone else agreed to pay a bill in the future. After doing this a couple of times, it actually turned into a sort of tradition in our friend group. Whenever we went out, one person would pay today, and the next time someone else covers it. Now, this sort of informal paid forward system isn't just unique to our group. Maybe many of you watching already had something like this and still do in your friend groups. And in a way, this system is a very simplified version of what any blockchain aims to do. But to make this system into a fully functional blockchain, you're going to have to introduce some new concepts to it, and a little bit of rules, structure, as well as security, which is what blockchain technology shines at. The thing is, both our paid forward system as well as a blockchain function on the same basis: trust. In our paid forward system, every member of the group records and acknowledges who covered the bill at what time. And this general consensus amongst my friends is actually what carried this entire system all the way until we graduated. Now, in the blockchain, instead of people doing all the tracking, it's done by millions of computers. And all of these computers come together to agree upon what happened in the blockchain and when. This general agreement amongst all of these computers is what we call a consensus in the blockchain. And this mechanism is the backbone of any blockchain, making sure all the transactions are validated and are accepted by the network. Now, here's where it gets interesting. Like I said before, in blockchains, we do not rely on human memory. Instead, we have all those millions of computers I just talked about. And these computers are what you call nodes. When someone makes a transaction on the blockchain, what happens is it gets broadcasted to all the nodes in the network. And each node then starts its own verification process using cryptographic checks, like to see if the sender has enough funds to make the transaction, or even to check if the signature is valid. If all of this checks out, the transaction then gets put into a waiting area called the mempool. Then, using a process we're going to talk about in a sec, the transaction finally gets added onto the blockchain. Now, here's the cool part about all of that. Every single node that we talked about actually keeps its own independent copy of the blockchain. It records every transaction that has ever happened in the blockchain on itself. And guess what? Despite being spread out all across the world, all of these copies of the blockchain are kept in perfect sync thanks to something called the consensus mechanism, which we'll talk about in a bit. But for now, I want you to understand that the blockchain is like millions of people comparing nodes to find out that every single copy of it is perfectly matching. That's the power of decentralization. Now that you understand the concept behind a blockchain, how do you exactly record transactions on it? Well, it's done using something called blocks. And the concept behind this is pretty simple to understand. They're just a digital container that hold a bunch of transactions that happened within the same time frame. Once a block is finally full, it's now ready to get added into the blockchain. And this is where things really start to get clever. Each of these blocks contains something called a cryptographic hash. Think of it like a unique fingerprint made up of all the things inside it. Every time a new block gets added onto the blockchain, its cryptographic hash will contain part of the previous block's hash as its own data. This hashing mechanism is what links the blocks together, hence the term blockchain. So what this means is if anyone tries to tamper with any of these blocks, it's going to completely mess up the cryptographic hash of every other box coming after it. That is what makes blockchain so secure. Alright, now we know if you add a block onto the chain, there's no way you can change it without messing up the entire thing. But what's stopping someone from adding a fake block onto the chain? That's what we're going to talk about now. Enter the consensus mechanism from before. This is the mechanism used by a blockchain to make sure everyone agrees on what's legit and what's not. And here are the two most common ones: proof of work and proof of stake. In proof of work used by Bitcoins, computers compete to solve complex puzzles, and the first one to complete it gets to add their block onto the chain. Proof of stake, on the other hand, like what's used by Ethereum, this is where people stake their crypto to validate transactions. So if you cheat, you lose out on all your stake. Thanks to systems like these, only the blocks that pass the network's tests make it onto the chain, making sure all of it is secure and in sync. Pretty wild, right? What we just talked about today only scratches the surface of what Web3 has to offer. Underneath all of this, blockchain tech includes stuff like smart contracts, advanced cryptography, and many more tools that you use to build in DeFi, as well as stuff like NFTs. If you ever feel like you want to dig a little bit deeper into the world of Web3 and even build something in it, I recommend you check out Metana's Web3 Beginner Bootcamp. In it, we take you from having zero experience to a confident developer who can build anything on Web3 with real-world projects, expert mentorship, and even a 100% job guarantee at the end. The link's in the description if you ever want to check it out. With that, thanks for watching, and I'll catch you in the next one.